So we have two main objectives, but the ones we're going to focus on are the trigonometric equations. For both of them, we'll probably do inequalities on part 2. So here, they're given two equations. We have regular sine of 1/2 and arc sine of 1/2. And they're asking, are these two equations equivalent? Well, the answer is no, and it's basically because this one has more answers because you can use the whole unit circle. So you have an answer here and here, where they're both the same for sine, where it's 1/2. But for arc sine, we could only use what's in the first quadrant or the fourth quadrant, and this is the only place where arc sine is positive 1/2. So they're not equivalent because this one has two answers where it's 1/2. This only has one answer, because this one has a restriction. So basically, kind of like what we just did with the sine of x equals 1/2, and we know that they had answers at pi over 6 and 5 pi over 6. But that's just if you do one rotation around the unit circle, if you only have one period of 2 pi. But what happens when you have multiple periods? Well, that means when you go a second time around, a third time around, well, you would have to add to the pi over 6, you would have to add pi over 2, and now your next one would be 13 pi over 6. And for pi over 6, you would have to add 2 pi, you get 17 pi over 6. So we have multiple answers. So sine of x equals 1/2 has many answers because you can go multiple times around the unit circle. So that's what we're going to be working on today, writing all those kind of multiple answers in a general form. So here's a quick example of what I was talking about. For example, like the one we were talking about sine of x equals 1/2. Pi over 6 and 5 pi over 6 is where we actually have them in the first and second quadrant in the unit circle. If we want to make a general solution for all the possibilities, doesn't matter how many times we go around the unit circle, we go plus 2 pi k, where k is an integer. And we have to go 2 pi because we know that the period of a sine function is 2 pi, so this is why we have 2 pi k. Same thing for cosine of 1/2. And again, this is general. I'm just giving you quick examples for sine, cosine, and tangent. So like sine of 1/2 or cosine of x equals 1/2, you get it at pi over 3 and 5 pi over 3. If you want to make the general formula for this one, again, we know that for cosine, the period is 2 pi, so you go 2 pi times k, again, where k is an integer. And k is an integer. And if you don't want to write the word like that, you could also write it as k is an element of the integer. And I think you guys have seen me write that before. And then for tangent, we have pi over 4 plus pi k. This one, technically, you could write two answers, but you don't have to because the pi literally takes you to the next answer. So the period for a tangent is pi, so this is why this one is pi k, and these are 2 pi k because their period is 2 pi. So let's try to find these solutions. Like I said, I always start by writing this information down because I'm going to need it, and if I need to write figure out where cosine of this is in the unit circle, that's perfectly fine. Okay, so again, we're dealing with cosine, and it's a negative cosine. So we know cosine of negative square root of 2 over 2. We know it's positive in the first quadrant, but that's going to be negative in the second quadrant and in the third quadrant. So that means we would have it so we have pi over 4 is the only place. So that means it's going to be pi over 4, so we would have to see, so we're doing pi over 4. So let's make it so you can visually see it. So this is pi over 4. And I know it's pi over 4 because pi over 4 is the only one that has a square root of 2 over 2. I know it's positive here, but I need to figure out where they're negative. I know it's going to be negative here and here. So that means that's 1, 2, this is 3 pi over 4, 4, 5 pi over 4. That's the two places where it is. So that means if I want to write all the solutions, so I'm going to have x is equal to 3 pi over 4 plus my 2 pi k where k is an element of the integers, and my other answer would be 5 pi over 4 plus 2 pi k, where x is an element of the integers. That would be my solution. So pause the video and try example 2 and 3, and then unpause it to check your answers. So for sine of -1, we know sine is 1 here. That's positive 1. That means sine would be negative on the bottom half, and that would be pi over 2. So we're going and splitting up into halves. So pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. The only place where it's negative 1 is down here. So that means that's the only answer that I have. So that would be x is equal to 3 pi over 2 plus 2 pi k, because that's the one whole period, where k is an element of the integers. Okay, for the next one, this right here, if you rewrite it, it would be square root of 3 over 2. Square root of 3 over 3. So we know that that one would be here, and we're talking about tangent. So we're talking about pi over 6. So that means we're cutting in our stuff into sixes. So this is pi over 6. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we have 12. And we want positive. So we know tangent is going to be positive in the first quadrant. And we know a negative times a negative is a positive, so that's also going to be in the third quadrant. So that would mean 7 pi over 6 would be where it's positive, because a negative divided by negative is a positive. So those would be our two answers. So we have x is equal to pi over 6 plus 2, not 2 pi k, because it's tangent, pi k, where k is an element of the integer. And then we have it at 7 pi over 6 plus pi k, because k is an element of the integers. So those should have been your answers. So above you see 4 steps to solving trigonometric equations. Isolate the trig function on one side of the equation, find the corresponding angle measurements in the unit circle, consider any domain restrictions depending on if they give you arc sine or anything like that, and write the solution or in the general solution. So it says, what are the values of theta where 6 sine of theta equals 3 square roots of 2? So what you want to do is get sine by itself. So I need to get this function by itself. So I'm going to get rid of the 6. That's 6 times sine. So I'm going to divide both sides by a 6. This is going to go away. Now I have sine of theta. And I'm going to reduce this, and that becomes square root of 2 over 2. If you look at your unit circle, let me put it. Okay, so if we look at our unit circle that we just did, we know that sine of square root of 2 over 2 is pi over 4 right here. So that means we have pi over 4 is one answer. But we also know that it's going to be positive. So it's positive here. And that means it's also going to be positive in the second quadrant. So in the second quadrant, if you go pi over 4, again, this is pi over 4, 2, 3 pi over 4 would be our other one. So we know it's going to be positive in these two quadrants. So it's going to be 3 pi over 4 plus 2 pi k. Remember, it's always going to be 2 pi k because that's the period, and then k is an element of the integers. So we're writing the general formula, and we can with this we can find all the answers where they equal to square root of 2 over 2. So these are your answers. So this one says let f of x equal 3 plus 2 cosine x and g of x equals 2. In the x plane, what are the coordinates of the point intersection of the graph f and g for this function? Okay, so basically what you're going to do is you're going to put the functions together. F of x is equal to g of x. Okay, so set them equal to each other. So I'm going to say pause the video and work it out and then check your answers with mine. This one, they want a specific answer. What are the answers? Because they give you an actual domain. So they don't want all the answers that are possible. They just want the 2 or the 1 answer that works with it. So all the answers that you're going to get. So pause the video now and work it out and see, then check your answer. So if you plugged it in, you get 2 cosine of x is equal to 2. You need to solve for cosine, so you need to get this by itself. So we're going to go subtract the 3 first for both sides, order operations. You're going to have 2 cosine of x is equal to -1. Divide both sides by 2. And now you get cosine of x equals -1/2. Well, if you look at your unit circle, we know cosine is going to be -1/2 at pi over 3. So that means here and here. So in first quadrant and second quadrant. So that means we have it at, sorry, my bad. It's not going to be here. It's going to be, oh, come on, erase. It's not going to be there. It's going to be in the second quadrant and in the fourth quadrant. So it's going to be at 2 pi over 3 and at 4 pi over 3. Because this one is pi over 3. So that'd be 1, 2, because technically for pi over 3, the y-axis is not there, and the x-axis, and that's it. Okay, so that means, since they only want the answers between 0 and 2 pi, that means only one time around. That means my answers are going just to be 2 pi over 3 and 4 pi over 3, since they don't want all the possible answers. They just want all the answers in this domain. So those are one of my restrictions. All this is saying is the way you write sine squared is, so sine squared could look like this or sine squared could look like this. That's about it. That does not mean you're squaring each piece. That means the whole piece is squared. Most people like to write it this way. I usually write it this way also. But that's basically anytime. And it's not just about sine. It could be cosine or tangent. So in the next 3 examples, I'm going to let you just work it out. So I'm going to say pause it and check your answer. I'm not going to explain the next ones. I'm just going to work it out for you. So try them out. The only comment I'm going to say is when you take the square root of anything, you're going to have a positive negative answer. That means I'm looking for where it's positive square root of 2 or square root of 3 over 2 and where it's negative square root of 3 over 2. So that means technically there are 2 places where it's positive, and it's positive here and it's positive here for sine. So those are my 2 answers, this one. And then they're negative in these 2 quadrants. So 4 pi over 3 and 5 pi over 3 are my negative answers for the square root of 3 over 2. So these are all my answers for this function. Again, I'm going to have you work on it. Remember, solve it, make it equal to 0, and find out all the answers in this domain. So it's just going to be some specific answers. You might have to factor here. So if you get stuck, play the video. So what I did was make them equal to 0 by subtracting the cosine. And then I noticed that they both had a cosine in common. So I factored one of them out. And there was leftover cosine plus 1 inside the binomial. And then because they're equal to 0, we could use a 0 product property and say this piece is equal to 0 and this piece is equal to 0. Now I have to find all the places where cosine is equal to 0 and where cosine is equal to -1. And we know if you do in your unit circle, -1 would be on the x-axis and 0 would be on the y-axis. So we're basically looking, this is where it's 0, sorry, that's where it's 1. This is where it's -1. This is where it's 0. This is where it's 0. This is where cosine. So that means cosine is 0 at pi over 2, which is this one right here, and 3 pi over 2. And cosine is -1. It's, sorry, just -1 at pi. So this one has 3 answers. These are your 3 answers because this is where it equals -1. Last example. Yay! So this is kind of like example number, I think number 5 that we did. You're going to make them equal to each other and solve again. So we're going to have, you're going to have your f of x is equal to your g of x. So again, I would suggest you pause it and try it, and then you check your answers with the video. So I say pause now. So we're going to see our f of x is 2 sine of x, that's squared, is equal to square root of 3. We need to make it equal to 0. Sine of x. I almost forgot that piece. So we're going to subtract that to the other side, and we're going to get 2 sine squared of x minus the square root of 3 sine of x is equal to 0. They both have at least a sign in common, so I'm going to take that out. I'm going to factor it. And then leftovers be 2 sine of x minus the square root of 3 is equal to 0. And now we're going to use our zero product property. So we have sine of x is equal to 0. And then we have 2 sine of x minus the square root of 3 is equal to 0. And we're going to solve for that one. This would be 2 sine of x is equal to square root of 3. Divide both sides by 2. And you get square root of 3 over 2. And I have to find all the places where that equals 0 and square root of 3 over 2. So if you look at your unit circle, sine is equal to 0 here and here. And then where it equals square root of 3 over 2 would be when it is pi over 3. So if this is pi over 3 here, it also equals square root of 3 at 2 pi over 3. So this would be at 0 and at pi, because we're going this way around. So those are our answers, I believe. So we have x is equal to 0, pi over 3, 2 pi over 3, and pi. Those are all my answers where sine is equal to 0 and square root of 3 over 2. If you have any questions, just ask me on Friday when we come back and we could go over some of the questions you guys have.